This podcast will be covering the remainder theorem and the factor theorem. So the remainder theorem, in nerd speak, when a polynomial equation or function is divided by linear factor x minus r, the value of the remainder is the value of the equation or polynomial when x equals r. In plain, simple English, if I plug in the value of r for every x in the equation, I should get, and I will get, the same result as I would get when I found the denominator using synthetic division. What does this look like? I'm so glad you asked. I know you didn't actually ask, but, go with it. So let's go over here. So here we have a problem. X cubed plus 2x squared minus 3x minus 5. And I have r equals 2. So what this means is if I were to divide this polynomial by x minus 2, remember that comes from the whole x minus r, x minus c, whatever. X minus r, if r is 2, it'd be x minus 2. So I have this polynomial here. If I were to divide that by x minus 2 using synthetic division, my remainder would have the exact same value as if I just plugged in r right here. So let's do that. Let's do the, let's see, plug in, synthetic, eeny, meeny, miny, wombat. We'll do plugging in first. So replace every x with that r value. So 2 cubed plus 2 times 2 squared minus 3 times 2 minus 5. So 8, 2 squared is 4, times 2 more is 8, minus 6, minus 5. 16 minus 6 is 10, minus 5 is 5. So my value when r equals 2 is 5. So let's do the same thing with synthetic division. So let's do x cubed, let's see here. Just want to use the coefficients? No, bad. There we go. 1, 2, negative 3, negative 5. 1, 2, negative 3, negative 5. In the box I'm going to put 2. Draw the bar. Bring your first number down. And then commence the whole playing with the numbers thing. 2 times 1, 2. Put it there, add it, write it. 2 times 4, 8. Put it there, add it, write it. 2 times 5, 10. Put it down. Negative 5 plus 10 is 5. Remember, the last number in synthetic division is always your remainder value. My remainder value is 5. When I plugged it in, the 2, I got 5. I got the exact same value, either way. Which kind of makes this handy to find things sometimes. Like, if you just want to find the remainder. Not sure why you'd want to, but if you wanted to find the remainder, you could just plug in the value. Let's see here. 3x to the 5th minus 4x cubed plus 2x plus 1. I'll say r is 2. So if I ask you to find the remainder, all you'd have to do is plug in this number to these x's. So 3 times 2 to the 5th, minus, there we go, minus 4 times 2 to the 3rd, plus 2 times 2, plus 1. So let's see, 2 to the 5th is 32, times 3 is 96, 2 cubed is 8, times negative 4 minus 32, 2 times 2, 4, plus 1, let's see, 64, 68, 69. That means your remainder value, if you did your problem, would be 69, and then divided by whatever you divided by. In this case it would be 2, so x minus 2, what have you. So the remainder theorem is not particularly difficult. It just says that whether you plug it in or do synthetic division, you're going to get the same answer for your remainder. You can also use this to find the value at a specific point. For example, if we had 3x to the third plus 4x squared minus 2x minus 3, and it says f of x, just for example, make it to a function. If I said find f of 3, I could use synthetic division to find the value. If you do that, that is referred to as synthetic substitution, because you are substituting into the problem. So let's do that real quick. Put a 3 here in the outside. Let's see, 3, 4, -2, -3. Line 3. 3 times 3 is 9. 9 and 4 is 13. 3 times 13 is 39. Add that's 37. 111. 108. So this is your value right here. Your f of 3 is 108. So to plug in the 3 the long way, I would come up with the same answer. Let's see here. 3 times 3 cubed plus 4 times 3 squared minus 2 times 3 minus 3. So let's see, 2781 plus 36 minus 6, and then minus 3 got cut off somehow. Interesting. So 117 minus 6 minus 3, 108. There you go. There's your answer. So it's a little fast, fun way to plug in a value into an equation or polynomial function, whatever, and find the value at a specific point. And you do have the option of doing this and plugging things in. Yes, that's still a viable option. Or you can do synthetic substitution, which is also known as synthetic division. Just shh, don't tell them that. And it's really your choice. And it honestly is. Now, if you're plugging in negative signs, I'd recommend doing the synthetic substitution because it lessens the chance of making a button error on the calculator. You know, -2 to the third power and getting the wrong number, -2 to the fourth power, whatever. So that's remainder theorem. There's not a whole lot to it, really. It basically finds the value of the remainder for you. You plug in the number, your last number is your remainder. It's the value of the equation whenever x is this value here, whatever you plugged in. It's all the same thing. It's kind of a little cool, fun connection. Way that only I would find fun. Which is really all that matters in the end. If I'm having fun, you're having fun. So, the factor theorem. Now, what this theorem basically says is that you can find out whether or not what you're dividing by is a factor of something. Case in point, let's find an example here. Something fun. This looks good. A nice, fun, challenging problem. Sort of. So we have 2x cubed plus 3x squared plus 3x plus 2. And we want to know if x plus 1 is a factor. So what we're trying to do basically is figure out if we can divide this by x plus 1 and get a remainder of 0. To be a factor, it has to have no remainder. And that is basically what the factor theorem says. If your remainder is 0, then whatever you divide it by is a factor, which leads us into finding roots, which we'll be getting to in a couple of podcasts. Not quite yet, but in a little bit. So let's test this. All we're going to do is divide. I'm going to use synthetic division here. We could if we have to use long division, but since this is x to the first power, we can use synthetic, and quite frankly, I would rather use synthetic than long. Call me lazy, but I'm okay with that. So in the box, take the opposite sign, -1. See, x3, 2, 1 number, nothing is missing, so we're good. 2, 3, 3, 2. Put the bar, put the number. Whoa, geez, wrong number. If you're taking notes, erase that right there. You, in the back, stop laughing. No one's perfect, except for me. Multiply, -1 times 2, -2. Add, +1. -1 times 1, -1. Add, +2. -1 times 2, add, -2. 2 plus -2, 0. Our remainder is 0, which means that yes, x plus 1 is a factor. Now you could be asked to go further and find the other factors. Not doing that quite this second, but it will be, eventually coming to torment you. I'm sure that makes you extremely happy. Or not. So let's see what we got here. Let's try this one. Alright, we want to know if x plus 3 is a factor of x to the 7th minus 3x plus 2. So again, let's do some synthetic division. So -3. Now here we are missing a lot of them. We're missing x to the 6th, x to the 5th, 4th, 3rd, 2nd. So x to the 7th, x to the 6th, 5, 4, 3, 2, x to the 1st, and our number. And if you found the shortcut yet, please stop me. So go through and do your synthetic division and substitution, whatever you want to call it. Let's see, it goes there. Okay. We got space here very, very quickly, but that's okay. I don't mind. Since our remainder is not 0, it is not a factor. Now, I would say that right around this point here, you should have realized that, because the numbers are just getting bigger and bigger and bigger. Honestly, if you can tell at that point that it's not going to get any different, so you keep getting larger and larger and larger and larger, and not near 0, you can pretty much stop. You know it's not going to work. Now, the shortcut, for those in the side of the room there who are screaming at me, what about the shortcut? Well, remember what we said to do. The value of the remainder is the same thing as if I took -3 and then plugged it in to each x and worked it out. So you could have just plugged that right in there and then gotten your answer. And if it was 0, then it's a factor. If it was not 0, then it is not a factor. That's really how easy it is. Kind of scary, I know, but That's really it. So here's one for you to try. Let's see here. How about meeny, meeny, miny, crocodile? Yeah, you thought I was going to say wombat, didn't you? Yeah. Not this time. I am way ahead of you. Well, kind of. Not so much ahead of you as behind you, south of you. I don't know, I'm not really sure where to put it exactly. Let's go for a fun problem. This one looks pretty. Sorry. It's the cold. 2x to the fourth plus 7x cubed minus 11x squared plus 12x minus 40. And I want to know if x plus 5 is a factor. So go ahead and push the pause button, work it out. When you have your answer, hit the play button again, and we'll see what happens. Exciting, isn't it? Just go ahead, push pause, work it out. Seriously, push the pause button. What are you waiting for? Push the oh, you already pushed the pause, but never mind. So now that we're back, let's go ahead and work this problem out. Now again, we do have two choices. We can either use synthetic substitution, or we can go ahead and just plug the negative 5, because you have to use the opposite sign here, into those x's. Given all those exponents, I'm just going to go ahead and use the substitution method. So negative 5 goes here, 2, 7, negative 11, 12, negative 40. These are some somewhat scary numbers if you ask me. That's interesting looking. It's kind of like a skate park or something. Seriously? Forget it. So negative 5 times 2, negative 10. Add negative 3. Negative 5 and negative 3 gives you positive 15. Add that gives you 4. Negative 5 and 4 is negative 20. That is a 40, not a 46. Okay, where was I? Yes. Add those, you get negative 8. Negative 5 and negative 8 is positive 40. Add those two and you get 0. So since the remainder is 0, yes, x plus 5 is a factor. Did you get it right? Yay! Or boo if you got it wrong. Or poor you or something. Insert expression of sympathy here. Excellent. Everyone's happy now, aren't we? Yes? Good. I know I'm happy. That's all it takes for the factor theorem. You're going to be asked, is this a factor? Yes or no. You plug in and you see if it's a factor. Yes or no. Eventually we will turn to finding the other factors and finding all the roots. That's not here yet. Very, very soon, though. Very, very soon. This is just the remainder theorem and the factor theorem. That's it. That's all for this podcast. The next one will be up very, very soon. If it isn't already up, it might be up by the time you watch this. I don't know yet. So, as always, if you have any questions, you know where to find me. And I will see you next time.